Hello, and a very warm welcome to Cognito Key. Today, we're diving into something pretty amazing called soft computing. It's all about teaching machines to think a little bit more like us, to reason and adapt in a world that isn't always so black and white.
You know, when you think about it, your standard computer lives in a world of absolute certainty. It's either a 1 or a 0. It's true or it's false. But our world, it's filled with shades of gray, right? We say things like, maybe, sort of, or it's kind of warm in here. So the big question is, how can a machine that only gets black and white possibly understand all these beautiful, messy shades of gray?
Well, this brings us to two totally different ways to look at computing. On one hand, you've got hard computing. It's all about rigid logic. It needs everything to be super precise. But on the other hand, you have soft computing. This is where things get interesting. It uses flexible logic, it's totally okay with approximations, and it can handle uncertainty. The goal is to get something much closer to how we humans actually reason.
So here's what we've got lined up. We'll kick things off with the soft computing solution. Then we'll take a peek at the toolkit, the main methods behind it all. After that, we'll see where soft computing pops up in our world, and we'll wrap up by looking at why the future is, well, a little bit fuzzy.
Okay, let's get right into it. What exactly is this soft computing solution we're talking about? Really, it's all about learning to embrace the messiness of the real world to build smarter systems.
So, the formal definition says it's a team of methods working together to handle ambiguous real-life situations. Let's break that down. In simple terms, it's about building machines that can problem solve like a person. Machines that can give us really useful solutions to super complex problems, even if those solutions aren't 100% precise.
And here's the key. Look at what soft computing allows for. It doesn't just put up with things like imprecision, uncertainty, or partial truths. It actually uses them. Instead of flagging these things as errors, soft computing sees them as, just features of reality that can help find a good enough, workable answer.
So why bother with all this? The goal is super practical. It's about achieving what's called tractability, basically making impossibly big problems small enough to actually solve. It's also about building robust systems that don't just crash when they see messy data. And amazingly, it's about finding these really powerful solutions without breaking the bank.
So, how in the world does this all work? What are the actual tools in this cool new toolkit? Well, it really comes down to four main pillars that make soft computing possible. Here they are. We have fuzzy logic, neural networks, genetic algorithms, and support vector machines. Now, the most important thing to get here is that these aren't rivals. They're actually partners. They often work together, complementing each other to solve problems that any one of them couldn't handle alone.
All right, first up is fuzzy logic. This is literally where machines learn to understand maybe. Instead of just true or false, it looks at everything in between. This helps a system reason a lot more like a human, especially when the information is vague, like trying to decide if a room is warm or hot. It's not just one or the other, is it?
Next, we've got neural networks. And yep, this is inspired directly by our own brains. It's a whole network of artificial neurons that are trained, not programmed. They learn by looking at tons of data and tweaking their connections, and that's how they get so good at complex stuff like recognizing your face in a photo or understanding what you're saying.
Now, support vector machines, or SVMs. This might sound a bit technical, but the idea is actually quite clever. Imagine you have a bunch of dots on a page. Some are circles, some are squares, and they're all mixed up. An SVM's job is to draw the best possible line that separates the circles from the squares, creating the widest possible gap between them. It's a really powerful way to classify things. And last but not least, genetic algorithms. These are fascinating because they're inspired by Darwin's theory of evolution. You start with a whole population of possible solutions. You test how fit each one is, and then you let the best ones reproduce, combining their parts to create new, hopefully better solutions. It's literally survival of the fittest for finding the best answer.
So we've looked at the theory and the toolkit, but where do you actually see this stuff? Let's switch gears from the how to the where, because I promise you, these technologies are already all around us.
Soft computing is everywhere, hiding in plain sight. It's the magic behind the tech that can read your messy handwriting. It's in the complex systems running inside modern cars. It's the AI you play against in chess or poker. It helps big companies make smarter decisions, and it even helps design buildings and manage our power grids. It's pretty amazing.
So let's wrap this up and look at the big picture. What's the real importance of all this?
At its core, it's about building a bridge between that rigid, perfect machine logic and our own flexible, messy human reasoning.
This quote right here just says it all, doesn't it? The ultimate goal of soft computing is to give machines that same remarkable ability that we all have, the ability to find our way through a world that is rarely clear-cut and is almost always full of uncertainty.
And that leaves us with a really exciting question to think about. We are truly just getting started with this. As our machines get better and better at thinking in these shades of gray, what problems that seem impossible today will they help us solve next? Think about medicine or climate science. The possibilities are endless.
If you enjoyed this journey into soft computing and want to explore more topics like this with us, please hit that subscribe button for Cognito Key, and of course, don't forget to like and share this explainer so more people can find it. Thank you so much for watching, and we'll see you in the next one.